Hey guys, so today I want you guys to go through and work on this problem set. Now, this problem set may seem a little daunting. There's 21 problems on here, and I want you to write the Lewis structures for all of these guys. Some of them are going to be maybe a little challenging, but you can definitely do it. Just remember those steps that I mentioned before in Friday's video. There were like 6 different steps, right? So if you just kind of walk through those steps, then you should be able to write the Lewis structure for all of these guys. So this one actually is, there we go. There was a typo. Fixed it. Is it on the assignment as well? It is on the assignment as well. There we go. I might double check these. All right. So, all right. So I wanted to just go through and do these, do a few with you. I think I will do. Let's see. I'll do number 2. I'll do. Let's see. I'll do number 8. I'll do. I'll do 19. Let's see, what else do we got? I think I'll do these 3. Okay, I'll do like one easy one intermediate, and one that's a little more difficult. Okay. So, let's go ahead and start, shall we? So first off, HBr. Some of you guys may remember that this is hydrobromic acid, because it's a monoatomic ion, the Br, with a hydrogen in front of it, so it's an acid. An acid is going to have, if a monatomic ion acid has hydro, the thing, ic acid. So hydrobromic acid. All right. So hydrobromic acid has 1 H, 1 hydrogen, and 1 bromine, right? The Lewis structure for these guys, hydrogen has 1 electron, and bromine has 1, 2, 3, 4, 5, 6, 7 electrons. Already you can kind of see how this is going to turn out, right? But let's just kind of keep going through the process. So in order, we have all this. We know that bromine is going to have 1 bond. Hydrogen is going to have 1 bond. All right. So next up, we need to go through and arrange these guys. I mean, there's only 2, so there's only 1 real arrangement they can go in, right? And it's going to kind of look like this. Now let's think about how many electrons we have to play with. Bromine has 7, hydrogen has 1, so we have a total of 8 electrons that we can play around with. All right, so now let's go through and put in bonds. We know there's going to be at least 1 bond. Let me switch this to a different color. My bonds are going to be green. There's a bond. All right. So now we have a bond between those 2. We used each bond is them sharing electrons, right? So remember that they're going to each share 1 electron. So in 1 bond, there are going to be 2 electrons being shared, 1 from hydrogen, 1 from bromine. So now we're down to 6 electrons left. All right. So now we're going to go through and assign these 6 electrons to the most electronegative atom. So out of hydrogen and bromine, which one's the most electronegative? Bromine. So now we're going to go through and fill up all the other electrons until bromine has that full octet, 8. So now bromine has 8, and we used 1, 2, 3, 4, 5, 6. We've used all of them. We have 0 electrons left. Okay, next up, switch over to red. Now we're going to go through and check to see if everyone has an octet. So if we look at this bromine, and remember, this bond is being shared between both of them, so this acts like when we look at octet for bromine, these 2 electrons count. When we look for octet for hydrogen, these 2 count. So bromine has 1, 2, 3, 4, 5, 6, 7, 8. Bromine is good. It has an octet. For hydrogen, remember, since hydrogen only has that 1 s orbital, it's completely full at 2. So does it have 2? 1, 2. Check. We're good. Hooray! We don't have to do anything else. No other funny business. So there we go. Now we have a Lewis structure for hydrobromic acid. Fun times. So if you did that, you'll have a little check mark. You'll get number 2 correct. Wow, geez. What are the other ones? I did 8 and was it 19? I'm going to do 8 and 19. All right. So in this case, here we have NO minus, right? So this is an ion, NO minus. So this entire thing is going to have a negative charge. Okay. Let's just kind of go through the process. So we know there's going to be nitrogen. We know there's going to be oxygen. The the dot notation for these guys is going to be like this for nitrogen and this for oxygen. So we can kind of tell already that nitrogen's going to want 3 bonds, oxygen's going to want 2 bonds, and that's going to be about how it looks. Okay, so now let's go through and count electrons. So for nitrogen, there's going to be 5. For oxygen, there's going to be 6. And we have an negative charge here. So this negative charge means that we have 1 additional electron. Remember, an electron is negatively charged. So we have, if this entire thing is negative, there's going to be 1 more electron in the mix here. If we sum this together, we get 12 electrons. Okay. So now let's go through and think about the arrangement of these atoms. The arrangement, there's only 2 of them, so they're just going to be side by side. All right. And now we're going to go ahead and start putting in electrons. Switch back to my green. We know they're going to be connected at least by 1 bond. So that means that we can put that there. We are down to 10 electrons. Okay, so now we're going to go through and we're going to give out these 10 electrons based on electronegativity. So nitrogen and oxygen, which one's more electronegative? Oxygen is more electronegative. Remember the trend. So oxygen is going to get filled up with its octet first. So that's 1, 2, 3, 4, 5, 6, 7, 8. There we go. Now we have 8 electrons here. Okay, we used 8, we got 2 left. So now we're going to try to fill up nitrogen as much as we can. 1, 2. All right, so now nitrogen is all full and we ran out of electrons. Oh no, what can we do? Well, first off, let's go through and look at the octets. So for oxygen, does it have an octet? 1, 2, 3, 4, 5, 6, 7, 8. Oxygen has an octet. Nitrogen, 1, 2, 3, 4. No. So what are we going to do? We're going to need to share more. So we need to share more with these guys. Okay. So to share more, that means we are going to need to move some of these lone pair electrons, these electrons that belong just to oxygen. We're going to erase those and move them here to be a double bond. Okay, so now oxygen now has 1, 2, 3, 4, 5, 6, 7, 8. It's good. Nitrogen has 1, 2, 3, 4, 5, 6. Still not there. So I'm going to take another pair and make them share. So 1, 2, 3, 4, 5, 6, 7, 8. Oxygen is good. Nitrogen, 1, 2, 3, 4, 5, 6, 7, 8. Nitrogen is good. Hooray, they're all good. Now there's one more thing that I don't know if I mentioned in that video when dealing with ions. When dealing with ions, the appropriate thing to do is add a bracket around them and then add that negative charge, just to let people know when they look at this Lewis structure that this thing in the brackets is actually negatively charged. It's a negatively charged ion. Okay? So that's what's going on there. That's how you go about doing that. Okay. All right. Geez, 19. Okay. So here we have C2H2. C2H2. This is the thing. The common name for this is ethane. I'm sorry, not ethane. Ethine. So, yeah, let's go through it. So hydrogen. We know what hydrogen looks like. We did it before. Carbon has 1, 2, 3, 4 valence electrons. So that means we're going to have 4 bonds, or carbon's going to try to have 4 bonds associated with it. Okay, great. So we're going to go through now and see how to set this up. Now we have 2 hydrogens and 2 carbons. So 2 hydrogens at 1 apiece is going to give us 2 electrons. Then 2 carbons at 4 apiece is going to give us 8 electrons. If we add those together, we get 10 electrons. Okay, now let's go through and arrange these guys. Now the formula here is kind of giving you a little hint, right? But if you remember the rules, electronegatives are on the outside and hydrogens are always on the outside. No matter what, hydrogens are always on the outside. So we can kind of arrange this like so. This is going to be kind of how it's arranged. Okay, so now we can go through and add our bonds. We know each of these are going to be bound to each other. Something like this. So we have 1, 2, 3, 4, 5, 6. If we get rid of 6, then we're going to have 4 left. 4 left there. All right. Now we're going to go through and start adding these 4 to these guys. We have 2 carbons here. Which one are we going to use? Honestly, it doesn't matter. So we're going to start with this one. We're going to give it 4 more electrons to get it into an octet. All right. So now we're done. No more electrons to give. So now let's go through and check for those octets. This hydrogen has 1, 2. Check. This hydrogen 1, 2. Check. This carbon, 1, 2, 3, 4, 5, 6, 7, 8. Check. This poor carbon, 1, 2, 3, 4, it only has 4. It's going to need 4 more electrons. What do? We force them to share. We take those 2 lone pairs, or that 1 lone pair, and turn it into another bond. So now we have a double bond here. Double check it again. This carbon's still fine. This one now has 1, 2, 3, 4, 5, 6. Still not enough. So we do the same thing again. And there we go. Now we have 1, 2, 3, 4, 5, 6, 7, 8. This guy is now an octet. And there you go. That is going to be how this works. Some of these may be a little bit more confusing, but just remember those rules. Go back and watch that video again. It's on my YouTube channel if you don't want to go through and watch it with questions, but you can go through and watch it, pause it, and move forward and backward, go through the steps, and go ahead and fill these out. The big thing to remember is what to do with these ions here, 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 and here. For that, just remember if it's a negative, then you're going to add 1 more electron. If it's a positive, you subtract an ion. Or subtract an electron. So yeah. Okay. Hopefully that's good. You guys are doing well. I will, if you have any problems, again, email me. I will be around. and we're going to go over these on Tuesday. So if you have a question, if you could do most of them, but a few of them are tripping you up, just hold off until Tuesday. We're going to be going over them. But if you just cannot get a single one of these, go ahead and email me. We can set up a one-on-one meeting. All right. I will see you guys on Tuesday.